Okay, so that's our original function. In order to maximize, we want our derivative to be equal to 0. Okay, well, first things first, we need to find the derivative. Go ahead and find the derivative on your own. Here we have our derivative function. Setting it equal to 0 will give us x values of what? Our first x value is 4.06, and our second x value is 12.9. Remember, you can graph it and find the x-intercept, or you can use your polynomial root finder on your TI-84 or TI-Nspire. But those are your two x-intercepts. We need to figure out which one is the maximum and which one's the minimum, because they're not both maximums. So if we use our sign diagram, if I plug in 0 into the derivative, which would be over here, that would be a positive, which means it goes positive, negative, positive. If we were increasing and then decreasing and then increasing, this would be a minimum, which means that this would be a maximum at 4.06. So that would be our maximum because it was increasing and then it was decreasing. So that would be where our maximum occurs. When x equals 4.06, we have a maximum, but the question says, what is the maximum volume? Since we're finding the maximum volume, we are going to plug this value into our original function because our original function is a function of volume. So we need to find v of 4.06. You could plug this guy into your calculator, or you could just plug in 4.06 and calculate it. Tell me what you get. We end up getting 1,144 centimeters cubed. So that is our answer. Okay. This process is hard, and it might have made sense as I was explaining it. Hopefully, if not, ask questions the next time we see each other. But hopefully it makes sense as I'm explaining it, because it's supposed to make sense, because it's my job to make it make sense. But it's your job as a student to then figure out, what question is she asking me? What question is she asking herself? What is she creating? What dimensions has she put together? What has she labeled? What has she done? What functions has she put down? What is she doing that makes it make sense? And then you need to do that for yourself, right? My job is to make it make sense, but your job is to find what I'm doing and say, oh, I need to do that in order to make it make sense for myself. That is your job. So let's figure out how to get you to do that. We're going to find the dimensions of the open box first, though, before we move on to that. So if we want the dimensions of the open box, that means that we need to know what is length, what is width, and what is height. We know that height is just equal to x, width is equal to 30 minus 2x, and length is equal to 21 minus 2x. And we know from above that our volume is maximized when x equals 4.06, which means we plug 4.06 in for x and solve for length, width, and height. And that's it. Go ahead and solve. We get 12.9 for our length. For our width, we get 21.9. And for our height, it's just 4.06. And those are the maximum, those are the dimensions of an A4 paper that we could cut out squares from each corner and create a box such that we've created the largest volume of that box. Pretty cool. So I want to break down this thought process that we had about like how to create a model, how to make these equations, into questions you can ask yourself when you are going through a problem. And we're going to go through these questions for every single rest of these word problems in our notes. So just make sure to always reference back to them. Notice that I will ask myself first, do I understand this problem visually? Do I understand this problem visually? So I'm sure we can remember from like previous tests or previous things that like when we're given certain situations, that sometimes when I go back and re-explain, that like drawing the situation or showing you with like a piece of paper might be like the best way for you to understand. So how do you recreate that for yourself when I'm not there? How do you make it make sense for yourself? So drawing diagrams, even if they give you a diagram, even if you can put it on your calculator, redraw the situation, because having going through the process of drawing it, going through the process of understanding it visually is a key moment of understanding instinctually what's happening in that situation. We can always just rely on the diagram that's been given to us, but what if we go back and we relabel things in the diagram? What if we go back and say like, okay, well, if this is length and width and height, then that's length and that's width and then that's height, and then oh, okay, well then that's the connection here. But making these connections just automatically with length and width and height did not happen naturally. You had to have a visual representation that you could tangibly kind of like work with and understand the relationship in order to make it happen. So make sure that you are redrawing, even if they give you something, redraw the situation. Or just if they haven't, draw the situation. Um, Label dimensions. Figure out where do these numbers go that were given to you in the problem? Where do they go in this diagram? How do they help you? What are the connections? Okay, next question. What am I trying to optimize? And how can I make an equation for this? Okay, so optimize, because we're talking about optimization problems, but like we're not always talking about an optimization problem. Sometimes we're talking about a problem that's asking about this, but about something else. But take a second and ask yourself, like, what is this question asking me to focus on? It's asking me to optimize volume. Then I need to make an equation for volume. If it's asking me to talk about this situation and it says that it's directly varying with that thing, or if it says, hey, find an equation that represents profit, start putting together an equation that represents profit, even if it means just like profit equals cost minus sales, right? Or sales minus cost, but whatever, right? So like even if you just start from a very generic formula, and they typically are formulas that you know, they typically are generic formulas that you've worked with a bunch of times. But then your next step, the hard step, is to then manipulate this generic formula to make sure that it works in the way that you need it to. So it usually starts with a well-known formula. Even if it is just speed equals distance over time, right? You have a generic formula that you've written at the very top, and now you can have this idea of like, okay, I don't want length, I don't want width, I don't want height, I want it to all be in terms of x. How can I create equations that represent length and x together all at once so I can use substitution to get rid of it? So having that foundation, that starting spot, is like a to-do list. And you've heard this now from me for 2 years. So this to-do list is super important. Okay. Then you need to say, okay, I've got too many inputs. What is my goal input? If you usually start with a generic formula which has all inputs, all variables. And so you need to say, okay, then what is going to be my goal input? Is it going to be X, or do I want to put it all in terms of length? Or do I want to put it all in terms of radius, right? So then you need to figure out and isolate, okay, this needs to be my goal input. Typically in the problem, it gives you a hint, whether in the labeling of the diagram or whether it says like, hey, just letting you know, height equals 4x. And you're like, oh, well then height wouldn't be in there anymore. It would be 4x that's in there, which means I need to have inputs of only x in this. So that goal of like, okay, I've created a generic formula. Now, what is the input? What is the variable that needs to be in all of this side of the equation? So focus on one variable. It's typically indicated in the problem or sometimes in the diagram, right? So notice in that previous problem, it labeled something as X, right? So it's like, hey, this is an unknown, write your dimensions in terms of X. Once you figured out what your input needs to be, you need to make relationships, which are equations, right? Equations or formulas or functions that connect the variables you don't want with the variables you do want. This is where we do substitution, right? So we said, okay, we have length, width, and height in our previous one. We don't want length, width, and height. We want X. So then how do we make a connection between length and X? How do we make a connection between width and X? And then this is where you have to go in and kind of puzzle out, what are the connections here? Making more equations. Write down as many equations as you can with the goal of like, where could I use substitution here in order to plug things in?